Hey guys, so in this video we are going to be talking about how to just name some basic alkanes and getting into the whole nomenclature. So before we get to some practice problems, I kind of just wanted to go over some stuff that I wish I had been shown when I first started naming. So ignore these carbon chains for now at the top of these skeletal structures. What I want to focus on now is just this group. So this is going to be our methyl. And this CH3 is right here at the end. So each divot is our carbon. So we've got a carbon, a carbon, a carbon, a carbon, a carbon. So then this here is another carbon, just coming off this bigger line of carbons. And so this we would call a methyl group with just one carbon, and it's got 3 hydrogens on it. Come over here, again, just taking a look at this. These parent carbon chains are all the same. So we've got this carbon and this carbon. So we've got this line just drawn like that. So this is going to be our ethyl group. This is 2 carbons. Okay. Coming over here, we've got a propyl. So just looking at this, we've got a carbon, and another carbon. That's 3 carbons. This is what we're going to call a propyl when it's coming off of a bigger carbon chain. It's a substituent is what we call it, anything coming off that big chain. And coming on to this one is a butyl. So we've got 1, 2, 3, 4. This is our butyl group. So yeah, whenever you see these coming off a bigger parent chain like this, as we'll see in some examples, this is what we're going to name them. So if you got 1, 2, 3, or 4, methyl, ethyl, propyl, butyl. And then just coming over here, talking about these parent chains. So the parent chain is 1 carbon, methane. 2 carbons, ethane. 3 carbons, propane. 4 is butane. 5 is pentane. 6 is hexane. 7 is heptane. 8 is octane. 9 is nonane. And 10 is decane. And just to give you a little bit an idea of what I'm talking about here, just in case you have no clue. If we were to draw out propane, we would do 1, 2. So this would have 3 carbons. So we've got carbon here, a carbon here, a carbon here. If we wanted to do pentane, right? Just a little arrow, it would be, okay, so now we got 1, 2, 3, 4, 5. And just a little trick for drawing out these carbon chains without having to count, you know, how many am I drawing, whatever. Say I was drawing 7. I want to draw a heptane, so I need 7 carbons. I'm going to draw 6 lines. So the heptane would be 1, 2, 3, 4, 5, 6. So that's 1, 2, 3, 4, 5, 6, 7 carbons. If I wanted to do a nonane with 9 carbons, I would draw 8 lines. So it would look like 1, 2, 3, 4, 5, 6, 7, 8, 9. Oop, I think I drew 1 extra. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So I drew a decane here, but so we can just go ahead and put this here. A nonane would draw 8 lines. So if I had 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my nonane. And for the decane, I just draw 9. So I went 1, 2, 3, 4, 5, 6, 7, 8, 9. But that's going to be 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You get the gist. So these are just some things to keep in mind. If you remember these, they'll really help you out with naming. So let's go ahead and get to some practice problems. Okay, and getting into some practice problems, let's go ahead and start with this top left one. So if you are brand new to nomenclature, I recommend going ahead and getting familiar with the IUPAC rules, which will just give you the rules as to how to name these. So make sure you go ahead and get yourself familiar with those. And once you are, these are going to be some good practice problems to get you started and seeing how those rules work in real life. So getting started with this top left one here. I could name this, well, the first thing you want to do is find your longest parent carbon chain. So I could go 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So whichever direction I go in this molecule, I'm going to get a 5. I'm going to get a pentane. And so what I like to do while naming is just list everything I have. And then at the end, I'll put it all together. So I know I have a pentane. Okay. Now I'm going to look at what else I have. And right away, this jumps out at me. So this is a methyl group, just like we saw in the earlier page. So I want to make sure I get that in there. But I have to say where it is, because if I don't say where it is, it could be on the 1, 2, 3, 4, 5, wherever. So I want to make sure in the name, I know where the methyl is. So when naming it and when numbering it, I want to get it on the lowest number possible. So I want to go 1, 2, 3, 4, 5. If I do right to left, I have it on a 2. If I go 1, 2, 3, 4, 5, then I have it on a 4, and that's no fun. We want that on the lowest number possible. So I'm going to go ahead and say we have a 2 methyl. Okay. And that's all I have on this molecule. There's nothing else. So putting this together, we want to make sure that the parent carbon chain comes in the end. The substituents come first. I go in alphabetical order. And so let's go ahead and put this one all together. So I'm going to put my substituent first, which is my 2-methyl. And I have that dash in between the number and the name. And then I'm going to throw this pentane in as my carbon chain at the end. And that is the name for that molecule. So let's go ahead and get to the next one. First thing we do is identify our parent carbon chain. So just going to make that clear. That's just one carbon there at the end. So we could go 1, 2, 3, 4, 5, 6. We could go 1, 2, 3, 4, 5, 6. What if we went 1, 2, 3, 4, 5, 6, 7? And that is why we need to make sure we're always counting, because at first glance, this looks like a 6-parent carbon chain. But taking this extra group here into account, this is a heptane. 7 carbons. 1, 2, 3, 4, 5, 6, 7. So let's go ahead and write that out so that we've got it. Okay. Now, keeping this as our carbon chain, what's on it? I see this, and I see this. Those are 2 methyls on our carbon chain. So I'm going to list out where they are. First, I need to number this thing. So if I go, let's try this. If I go 1, 2, 3, 4, 5, 5, 6, 7. Okay. What if I went the other way? If I go 1, 2, 3, 4, 5, 6, 7. So going green, I have a 2 and I have a 5. Going blue, I have a 3 and 6. So the green going right to left is better in this case because I've got lower substituents. A 2 is better than a 3. And if we kept going, a 5 is better than a 6. So I'm going to say I have a 2, 5, and put this in blue, sorry. A 2, 5, dimethyl. And the reason I put di is to show I have 2. So if I had 3 methyls, I would say tri. And if I have 4 methyls, I would say tetra. Just got 2 here, so I put them together like this with a comma in between. Then I've got my dash, and then dimethyl. Okay, so let's go ahead and put this all together. 2, 5, right? Dimethylheptane. Okay, let's go ahead and move on to this one. This one is a lot easier than it looks. It's small, but for some reason for me, these small ones always kind of weird me out a little bit. They're just kind of strange to approach. So let's just do what we always do as our first step and identify our parent carbon chain. So I could go 1, 2, 3, 1, 2, 3, 1, 2, 3. No matter what direction, I'm getting a propane. Okay. Now if I say 1, 2, 3, 1, 2, 3, no matter what, my methyl group is on the 2. If I went 1, 2, 3, it's on the 2. 1, 2, 3, it's on the 2. So I'll just go ahead and say 1, 2, 3, but it really doesn't matter. You could go 1, 2, 3, because you're going to end up with the same name. So I'm going to say my 2-methyl. And now I'm just going to put it all together. So I've got a 2-methyl propane. Okay. Now, so far, we've only looked at skeletal structures, which just show the carbons. It doesn't show the hydrogens. Skeletal structures would also show functional groups, halogens, but we just haven't seen any of that yet. This is just a condensed structure, so it's going to show me the carbons and the hydrogens flat out. But the same rules apply, so nothing's going to change. So let's go ahead and identify our carbon chain, our longest parent carbon chain. So if I go 1, 2, 3, 4, 5, okay, 1, 2, 3, 4, 1, 2, 3, 4, 5, 2, 3, 4, 5, yeah, 1, 2, 3, 4, 5. Yeah, so no matter what, I'm getting a pentane here. That's my 5, okay. Now, looking at this 1, 2, 3, 4, 5, that's my parent carbon chain. What's on it now? Okay, well, I see a methyl and a methyl. Great. Okay, so I've got 1, 2, 3, 4, 5. And the reason I'm naming it this way is because if I went 1, 2, 3, 4, 5, then I would not have my substituents on the lowest number possible. I'd have a 3 and a 4 versus a 2 and a 3. So I've got a 2, 3 dimethyl. And let's just put that together. So 2, 3 dimethyl pentane. Okay. Now, this one is a bit more intimidating, but the same rules apply. Let's find our longest carbon chain. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? Let's try 1, 2, 3, 4, 5, 6, 7, no. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is going to be a non-name. Go ahead and just write that down so that we've got it. Now, we've got to figure out which way to number this. Another rule to keep in mind from the IU pack is you want to have the greatest amount of substituents possible on your carbon chain. So if you could have 1 substituent or 2 substituents, you want the one with 2. So if I go this way, I've got 1, okay, 2, 3, 4. If I go this way, I've got 1, 2, 3, 4, and 2. If I go this way, I go 1, 2, 3, 4. So I'm going to get 4 substituents no matter what. So now I want to make sure I have my substituents on the lowest number possible. So it's pretty clear on this one, this is not a symmetrical molecule. If I go this way, I'm going to get these 2 methyls as low as possible. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, let's just list out what we have on that chain. So here, I've got a 2, 2, 2 dimethyl. On here, I've got a 5 ethyl. And this guy here, 1, 2, 3, not counting the carbon on the parent chain. 1, 2, 3, I have a 6 propyl. And that's it. So now I'm just going to put this all together. Now, this has to be put in alphabetical order. So, just going by your A, B, C, D, we know 5 ethyl will come first. Okay. Now we've got A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So we're going to go 2 dimethyl. And then we're going to go with our 6 propyl and our nonane. So another thing to know here is we do not use this di in the methyl for our alphabetical order. Because if we did it when it came before ethyl, we're only focusing on this M here, okay? We don't look at the di for alphabetical. If it was tetra, if it was tri, no matter what, we're just looking at this M. If you had a diethyl, you're looking at the E. If you had a dipropyl, you're just looking at the P. Okay. So let's go with this one. So this is our first cyclic compound. The only thing we change is adding cyclo to the name. So let's continue with our rules. We want the longest chain, but with cyclic compounds, you want to, so if this chain here kept going and was greater, had more carbons than this, then this would be considered a substituent with this as the parent chain. But in this example, 1, 2, 3, 4, 5, 6, and then 1, 2, these are our substituents because this is longer. The cyclic compound is a bigger parent chain. So now we just need to figure out which way to number it. We could go this way, this way, this way, or this way. So if I start going 1, 2, 3, 4, 5, 6, okay. What if I went 1, 2, 3, 4, 5, 6? Either way, you have a 1 substituent and a 2 substituent. So how do we break this tie? Well, right here is our ethyl, and right here is our methyl. Now, either way, you have a 1, 2. You want to go this way. Why would we do that? Well, what's breaking the tie? Well, what's breaking the tie is the alphabet. So, because either way you're getting the same number, the next way to break the tie is the alphabet, because we've got the same number of substituents either way, too. But here we have an ethyl, and here we have a methyl. So this ethyl is going to get number 1 if we have a tie, because it's simply because E comes before M in the alphabet. So let's just figure out what we know. We have a cyclohexane. And so it's literally the same thing. You just add cyclo. Okay? We've got a 1 ethyl and a 2 methyl. Now, let's just go ahead and put it together in alphabetical order. So 1 ethyl, okay, 2 methyl, cyclohexane. And so with cyclic alkenes, with skeletal alkanes, with condensed alkanes, the same rules are going to apply. The only really tweak you're going to get is adding cyclo and little things like that. But overall, you're going to follow the same rules. And so this was just a quick tutorial and some practice problems on how to name alkanes. Hope you guys enjoyed the video. I'll be back with more practice problems soon. Thank you guys.